Aiken, and we're about to start our Trig unit. So I invited a friend of mine, Joe Kreidler, here to talk a little bit about Trig and how we use it in real life. So Joe, tell us a little bit about yourself first.
Yeah, hello everyone. I am an engineer, so I have a bachelor's degree in electrical engineering from the University of Illinois, and I have a master's degree in computer science from the Illinois Institute of Technology. I've worked at Motorola for over 20 years in cellular infrastructure, which is the cellular equipment, the base stations, and a large portion of that was working on mobile phones as well. So I spent a lot of time building cameras in mobile phones. I know a lot of you have phones and use cameras. If you've used a Motorola phone, you are probably using software that I wrote and my team wrote. But yeah, Mrs. Aiken asked me to stop by and kind of have us chat about Trig a little bit. And the interesting thing about Trig is I use it in work almost every day, and it's impacting your life every day. It is all around you. So let me share some examples for you. For starters, if you look in your home, you have electrical outlets all over the place. That signal coming in to your house is in the shape of a sine wave. And if you know about an outlet, it's 120 volts and it's 60 hertz. So 120 volts is the amplitude of the signal, and 60 hertz is how fast the signal is going up and down.
So is that what these numbers mean on my light bulb, Joe?
Exactly. You got to get the right, you got to get the light bulb to match the power coming out of the wall socket. So, so anything you use with electricity, that's all being delivered from ComEd to your home using a sine wave. You also experience Trig in music. So if you play a musical instrument, I did in high school. For example, I know the A note is 440 hertz. That sine wave goes up and down 440 times a second. So any musical instrument is producing a sound, and the sound is in the shape of a sine wave. So that's pretty interesting. And then, you know, as I said, I worked at Motorola. I worked on phones. A cell phone would not work at all without trigonometry. It is just full of trigonometry. So any kind of radio signal is sent out as a sine wave. So you can get your cellular signal, so you can actually talk on the phone. You have Wi-Fi typically in your phone. That's using sine waves. You have a Bluetooth chip in there as well. That's using sine waves. So all of that, it wouldn't be possible if it wasn't for trigonometry. What's interesting to me, hopefully you find interesting as well, if you take a picture, that picture is usually stored as a JPEG file, and that is a compressed picture. A cosine function is actually used to compress that picture so it fits in your memory on your phone. Same with videos and same with MP3 files. Those are all compressed using trigonometry. So it's around you, cell phones, electricity, music, everywhere you go, you're encountering trigonometry every day.
So we're going to be studying in Trig. We're going to be studying on the sine wave. We're going to be studying how high, how far up and down that wave goes. So that is our amplitude. We're going to be learning about amplitude, and then we're also going to be talking about frequency, which Joe mentioned here a minute ago, and that's how many bumps per second, or how many cycles per second. Let's be a little technical. How many cycles per second that sine wave is bouncing back and forth. So that's a difference between like our radio signals, right? Isn't that what you said on our radio station?
Yeah, so I don't know how many people know this, but if you get in a car and you tune your FM radio, usually you select a number. That number is the frequency of the signal that the radio station is transmitting. So 101.9, 103.5, you're actually tuning the radio to a different frequency to be able to hear that station.
Mm-hmm. And that's how many times, again, how many times that is bouncing up and back in per second.
Exactly.
Yeah.
So 101.9 is going up and down 100 million times a second.
Which is faster than 96.3. Much faster, right?
Exactly.
Yeah. Well, great. All right, well, thanks, Joe, for introducing Trig to us, and hopefully this will inspire them to pay attention to my lessons in class, yeah, thanks.
Enjoy.
Awesome. I think that was perfect.
Good.
You did great. Like,
Nice.
seriously. I mean, I think that's, yeah.